Hey guys, so I'm Alex Stevens. I'm tech director of Organic Humans. It's basically a two-man team. It's me, who's a programmer, and my co-developer Garth Robertson, who's the designer and artist. And I'm here to talk to you guys about virtual reality in Unreal Engine 4. How many guys actually develop in Unreal Engine here? Okay, got a few. Most of you guys are new, I guess. Yep, definitely the guys waving their hands in the back. Cool. How about any VR guys at all? Many people, few people, sweet, awesome. Okay, cool. Let's hopefully, come on. There we go, sweet. All right, so I'll just give a bit of a brief introduction to myself. So I originally studied mechatronic engineering, so I didn't actually study or anything like that, any game design or anything. I started off as more of a robotics guy, going into embedded software and all that stuff. I'm the lead programmer of Organic Humans, so I do everything in C++, touch a lot of blueprints and all that stuff, and pretty much do a lot of design for the VR side of things of our game. And we're currently in Steam Early Access. So it's Montas is a first-person survival horror. It's very much, it's not jump scares or anything like that, very much a suspenseful type of horror game. It's very much a lot of environment and all that stuff, a lot of slow build-up and all that. And we're hoping to release by about October. It's not set in stone, but we're trying to align ourselves with the PlayStation VR release. So obviously, if I'm talking about this, we're VR enabled, so we're building the game for Oculus Rift and PSVR. And unfortunately, we don't have a Vive dev kit, but we'll probably have to hunt down the VR Club and borrow one for a little while. And we originally started building this game in Unreal Development Kit. And unfortunately, with the release of Unreal Engine 4, a lot of that stuff has just been put to the wayside. So we didn't have source access to Unreal Engine 3, which sucked a bit. So we couldn't actually get all of the new SDKs for Oculus and Vive and all that stuff and implement them in Unreal Engine 3. So we made the decision to just migrate to Unreal Engine 4. And part of that decision was that we're going to be making future games with a base foundation or VR foundation, and we may as well do the migration now and then have a very firm base and ground when we go and design future games. And we're developing this game for Windows, OS X, Linux, and PS4. So hopefully by the end of the year, you'll hear a little bit more about us. And also helping out Jono with co-organizing the Brisbane Unreal Engine meetup. So we're going to try and have one of our first meetup events in the next month. So definitely check out our meetup page about that. We'll keep that up to date as much as possible. And I'm a bit of an Unreal Engine fanboy. I've used Unity a little bit, but nowhere near as much as Unreal Engine, so bear with me. I'll try and keep it general though. All right, so history of Montas. It was originally started by my co-developer, Garth. He's the artist and designer. We threw it onto Greenlight, and then suddenly in that first week, the Oculus Dev Kit 1 Kickstarter popped up, and we're like, actually, this is like a perfect platform. And it kind of like, it was like a sign. We were very much like, okay, we're going to like adjust our design a little bit and go directly for VR and try and design everything for VR straight off the bat. So I joined the project probably about 3 months after Garth started it, and then we focused all of our design and all that stuff towards the Dev Kit 1. So we were greenlit, and then we put ourselves up onto early access in March of 2014. So we're still on early access with our UDK build, so it's taken about a year so far for us to get up to about the same point in UE4, but we haven't made a release back to early access. So hopefully in the next month or two, we'll get that first build up. And we've had 7 major updates to date on early access with the UDK build, and then hopefully our biggest update will come out with UE4. Yeah, okay. All right, so what's this talk about? Montas is mostly a first-person game. We do have like a few little things where we might have like a painting cinematic or something like that, but not that often. We're doing everything mostly for head-mounted displays and all that stuff. We don't, as of yet, have motion input with hand controls or anything like that, but we're going to try and support stuff like the Omni treadmill and all that, and obviously walking around in the space of like for a Vive or something like that. And we're targeting, yeah, obviously Oculus and PSVR. So this talk, I'm going to talk mostly about when to use HMDs, trying to get the most out of it, what not to do especially, because there's a lot of things that people will go, I want to design a game where it's like, we're going to fly around as like Iron Man or something like that and really like blow up stuff and have like heaps of fast-paced action and all that stuff. And what they don't realize is they're probably going to create a vomit comet. And yeah, and plus a little bit about Unreal Engine and optimizing your game in Unreal Engine for VR and all that stuff. And obviously UE4 implementation of first-person view. Cool, fingers crossed. So, what are the best uses of head-mounted displays? So the best, have you guys seen many VR games or played with them? Have you guys played with Kieran Lord's hoverboard simulator by any chance? Maybe? Who's been down to GCAP or in the last few years? Maybe one? Okay. So there's like a lot of virtual reality games out there currently, especially on like the Oculus store, which have like a few little betas there. You can download a few of these, but the best ones I've found are like driving simulators. So kind of like sitting behind the steering wheel and having the headset on and sitting in a car. It kind of like tricks your head into thinking, hey, you're actually in a car. Like you're sitting down, you've got the steering wheel in front of you, and it feels like a real car, just without the G-force and all that stuff. So I find those are the best uses of VR. Great is first person, but you want to keep to stuff that's very slow paced. So like walking around in an environment that's very realistic. So like all of your scale and all that stuff is probably one-to-one. You can kind of go into games where like have you guys heard of the game Among the Sleep by any chance? It's kind of like a game where you play as a baby and it's you like crawl around and all that stuff and you're like this tiny little thing and everything's massive and it's really surreal. But if you keep kind of a consistent design, it works really well. But horrible uses of VR are stuff like third-person games, especially ones where the camera will be behind and you do a full 360 pan or something like that. You want to really, for first person, keep like a very like restricted motion and kind of like it's kind of like a railroad effect where you're always following a certain path that goes forwards and really only turn a certain amount. But otherwise, any view where the camera will like rip your head around and make you throw up like in a few seconds is probably the worst type of game that you could do. So stuff like I've seen some pretty cool demos where it's kind of like you're looking down, I think at the, what was it, the Brisbane Film Festival, I think it was. I can't remember what it's called. There was a game there that was kind of like you look over and it's kind of like you're a god and you're kind of like telling a little character where to move and all that stuff, and that works really well as well because you're sitting there really just static in the environment and looking around. And here we go. All right. So speaking of stuff that will make you throw up and all that stuff, so I was talking about third-person cameras like really doing people's heads in VR. So another few things that can really affect people's experiences, because like what a lot of people don't realize about VR is that even with the most basic VR experience, it is probably the most immersive thing you can do. Even just having like a simple scene where you've got a few objects that you're moving around, or like just walking around and having a look at art in like a museum or something like that, or in an art gallery or something. Even that effect of VR on someone's like experience is just super amazing. So anything that's a little bit uncanny or can make them feel like, hey, this is a little bit unrealistic, like e.g. getting crash tackled by like some big dinosaur and starting to try and rip your head off or something like that, it's probably going to make them sick. Mostly because they don't feel that in real life. The only senses that they get is really their visual senses and auditory. So focus on those two things, definitely. So the main things that, to start off with VR is don't do these things. So like ramping your movement speeds to the max, like some people go, yeah, I'm gonna play the Scout in TF2 in VR. You're running around probably, I think I remember reading that the Scout runs at about 65 kilometers an hour or something like that. So you can imagine that that instantaneous like acceleration is gonna really screw with people's heads. Stuff like user interfaces, in some engines, these aren't like supported very well. Back in the day when Unreal Engine 4 first came out and started supporting the Oculus, when you put up the Slate user interface and started loading that stuff up, it wouldn't actually account for your two views, like your two eyes. So you would only have like one rendered like UI over the top of the whole screen. So you get this cross-eye effect and like feel very bad. So what you want to do is you want to try and have something with some kind of depth in there at all times. So UI that might be rendered to a flat plane inside the world. So for Montas, that's what we usually do, is try and have something that's at probably around about arm's length. So it's not like going around with you at all times. You can kind of like look around, it'll be static in space, but then attached to you. With rotations as well, like a big thing is like don't control the player's like head or anything like that. So rotating the player's view, like if you're if you're running around or something like that and you've got the player's input can control their like yaw of the actual full body, that's ripping their head around without them feeling that like feedback. So what you want to do is you want to have all of your input from VR is very much looking around and controlling absolutely everything that's in game. I'll go into more detail about this later anyway. I've already mentioned the crash tackle, don't do that. Instant acceleration is a pretty bad thing unless the player is controlling it. And don't change the field of view. Like this is a big thing. A lot of people will go, yeah, let's implement like a scope or something like that in VR, and then suddenly like they'll just change the field of view of the whole camera, which is super bad. Like you have to start thinking outside the box. Like a lot of games will just pull in the view of the whole screen and put that into like a separate camera within a scope or something like that. So say stuff like COD and all that stuff, they will do that. But in VR, like imagine suddenly like pulling up, if you've got your physical like controller or something like that, you pull up a gun and then your view snaps into the scope and then changes the field of view. You're gonna feel pretty nauseous about that. So don't do that. And low frame rates, this is like the massive thing about VR, is that latency is an issue. As soon as you get some kind of disconnect between your input and your view, you'll start getting like super nauseous. So a lot of VR devs battle is literally just trying to optimize the heck out of their game. So a lot of games, like a lot of people I talk to, when they want to start VR, they'll go, hey, I want to go for like super realistic graphics and like amazing lighting and all this stuff. And while great in like a small little scene, when you go into something that's like open-ended and massive and all that stuff, it's really bad on frame rate. Because there are some optimizations these days, like where they'll do stereo rendering and kind of like improve the speed at which draw calls, like you send one draw call and then both sides of the screen will render on the GPU. They'll like save and shave a lot of stuff from your frame rates, but a lot of the time you're expecting like half the frame rates just from using VR. Like it's not exactly half, but you'll get to the point where you'll put something in the scene and put VR on and then check that with just a normal rendered scene or something like that, exact same scenario, and you'll get an instant drop of frame rates. It's something unavoidable with VR because you're essentially have two cameras per eye, or well, sorry, not two cameras per eye, but two cameras in the scene for your head, and that is going to capture both sides. So you're pretty much rendering a whole scene twice, essentially. So when you're thinking about your games and all that stuff, don't go for stuff that's super intensive on the shader or anything like that. Anything that is really struggling with just a normal screen, avoid at all costs, because it's going to be a nightmare to optimize in VR. And yeah, so that's frame rates and head bob. Any type of camera animation is the worst that you could absolutely do for any person. Imagine in real life, you're kind of like sitting there and there's some guy that's kind of like tearing your head around and rotating it and all that stuff perpetually through your whole game experience. You're gonna sit there and be like, bugger off, like I wanna control this. It's like very uncomfortable and people are not gonna like it at all. All right, cool. So once again, keep speeds to real life, keep using, has that duplicated or have I just gone back? Okay, all right, sorry. So keep user interfaces at a distance from the player, only move the camera in the game if the player tells it to, don't change the FOV, and highest frame rate. On the Dev Kit 2, 75 frames per second. On the Vive and the Oculus consumer versions, they're 90 frames per second. And don't use motion blur. Try and like just keep post-process effects out of your game as much as possible. Right, so virtual reality in Unreal Engine 4. It currently supports the Oculus Rift and Steam VR, so anything that supports that sort of APIs, like the Vive. It supports Gear VR and PSVR. It can support any HMD if you want. So if you buy a head-mounted display or something like that, and they supply a SDK, but the engine doesn't support it, you can hook in through the head-mounted display interface. So you can implement that stuff yourself. Yeah, Unreal Engine will support everything out of the box pretty much. Like most of the interface supports the basic stuff like IPD, which is interpupillary distance, and also screen percentages and all that stuff. And they will handle all of the rendering for you. And screen percentage is kind of like, when you render your scene, you want to cut down the resolution of the game that's rendered inside the screen per eye, and then blend them together. And that basically controls how high a resolution you want over the top of the existing resolution of the HMD is. So if you imagine, so have you guys actually played with a virtual reality headset at all? It's got like you've got your lenses in there, and it kind of distorts everything. So if you imagine that you want to use as much of the panel as possible, those lenses are going to be jumping in there and squeezing all of the picture in and kind of like distorting it. So the biggest problem is that if you're using the maximum amount of that display inside or the panel inside the virtual reality headset, if that lens is squishing everything, it's going to pull in black edges and all that stuff. So what happens is that the distortion that happens is that you need to render a slightly higher resolution and then squish it down and distort afterwards in a post-process. And that stuff happens automatically in-game, but you can control how high of a resolution that little upscaled resolution is. And then when you squeeze it down, if you drop that resolution, you can make it look a lot more pixelated, which will give you a lot more performance, or you can increase it and make it look pretty and all that stuff. But yeah, you can play around with that for your performance and all that stuff. And Unreal Engine supports hand tracking, so I haven't used this personally, but I know that like Leap Motion, have you guys seen that? It's like a little bar that detects your fingertips in space and all that stuff. You can use that to control stuff in Engine. They have a plugin for that. And Steam VR with the Vive and all that, you can use your, your hand tracking and all that stuff as well. All right. So how do we optimize your HMD experience in UE4? So the three things that we want is high frame rate and a low motion to photon latency and a clear image. So motion to photon is pretty much like when you move your head, you want to see that happen on the screen in front of you as soon as possible. So there's been a few little studies done saying that if you get underneath the 7 milliseconds mark, it's all right, but you want to get a lot lower than that. It's a lot harder. Like if you think about it, 7 milliseconds is what? So 100 divided by 7, over 100 frames per second easily. Anyway, but it's like a very high frame rate. And most of the headsets these days only support 90 frames per second or 90 hertz. So we want to optimally get everything as close to possible as on that headset as possible. But motion to photon is like a big thing that is in research at the moment for VR. It's really something that needs to be pulled down to make it more consumer friendly. But also the biggest thing is that hardware like graphics cards and all that stuff have to pick up their game a lot more in the near future if VR is going to really be pulled off. And we're slowly getting there. So how do we get to a high frame rate in VR? Try and disable most process effects like motion blur and depth of field. Your eyes, when you're looking in game and all that stuff, are most likely going to do this for you. You can do artificial depth of field and all that stuff, which is cool. But yeah, it's not overly needed. Modify your screen percentage, so changing that upscaled resolution. Increase for more detail, decrease for less, but you get more performance. And minimize the number of draw calls. So a draw call in most game engines and all that stuff will be like pushing a 3D object into the scene and also its material shader. So for each object in the scene, you're most likely going to get 2 draw calls. So what you can do to mitigate the number of draw calls in any one scene is LODs. So you could just put together many of those, 3D objects, and at a distance have them downscaled, have less polys and all that stuff, but clumped together. So there's SDKs like Simplygon, which does this automatically for you, which is awesome. It helps a lot with your performance and overall drops the number of draw calls. So then you're not what's called CPU limited on your VR game. Once again, cut down on the post-process and check out in UE4 anyway. In Unity, it's slightly different. You can change the configuration for Unity, I think. I'm not a big Unity guy, but same thing in UE4. You can change your rendering config. The Epic guys have already been developing like an optimal VR config, and that should be coming out in 4.12, I think. So you'll have most of this done out of the box for you guys. And also, check out the CPU and GPU profiles in Engine. So UE4 is really good in the regard that you can just spit out all of this data about how your games are like playing and all that stuff in terms of performance. You can do a lot of analytics in game and all that stuff. And you really want to do this from day one. Because if you start making a scene that looks super pretty, there's thousands of lights everywhere and all that stuff, probably going to have an enjoyable time trying to optimize the heck out of that thing. All right. So what about your assets and worlds? So don't expect normal maps to do too well. They're all right. Like from a distance, if you know what normal maps do, it's kind of like a light effect. It's like a flat plane. It'll make something look ripply or something like that and make it look like it's bent and curved. But in reality, on that surface, it's just perfectly flat. They work great in VR at a distance only, because if you imagine, you can kind of like get down really close to an object and you can see, oh wait, that's just a flat object. There's no ripples or anything like that. So in VR, what you can use is LODs, as I said before, to really, we call it a hero piece, where you get close to something and then you'll have like a really high poly version of that. When you move away from it, it will drop down and then you can start using a normal map to make it look a little bit more ripply. Keep your lighting to a minimum. Like if you've got tons of dynamic lights, you're probably going to kill your engine. Use a lot of baked lighting. So UE4 uses a system called light mass. This pretty much like will statically bake all of your lights into a little texture that's kept on every single object in the scene. And same thing with shadows. Anything that's dynamic lighting or shadows in game will kill your performance. Use a lot of focal points in your level to attract attention. So like in Montas, in the first version in UDK, we have like when you walk out into a street, you have like a little car that comes driving at you and all that stuff. It really captures your attention and all that stuff. There's a lot of things in VR, like when we first started demoing down in in PAX, a lot of people, they would jump into the world and be in awe. It's like, oh my God, this is amazing. And half the time, they'll miss small things. They want to look at the big things, the bigger picture. So in the UE4 version, we've got a lot of rooms where there'll be like this massive whale in like a museum or something like that. Or like, I can show you after the presentation, but like a mammoth skeleton, which has like enough detail to be like looking around and looking inside of it and going, oh, this is really cool. But stuff like that really captures people's attention and all that stuff. It's something that isn't really to do with performance or anything like that, but it makes people feel like, oh my God, this is an experience, and it's stuff that they remember. But yeah, speaking of scale with the mammoth and all that stuff, try and keep a scale that feels normal, or at least something that's consistent. If you constantly change the scale of someone in game, they're probably going to feel a little bit odd. We even have, like in Montas, we don't really give the option to change someone's height. So if you're like a 6'5" guy and you jump into Montas, our height's around about 175 centimeters. So you'll be like, oh my God, this is how it feels to be short. Or like if you're like a midget and then you jump in, you'll feel tall. It's something that like down in PAX, we had this, it's a 6'4" guy or something like that. And it's like, wow, like I feel really tiny in this. And it felt a little bit unusual. But I've still yet to experiment with like giving the option to like change height. But the problem is in terms of games and all that stuff, if you start allowing the option to change someone's height, you have to think about, how about crouching? How about jumping? Like, what's the height and scale of everything else? Like, in Montas, we want to allow people to crawl onto tables and all that stuff. Suddenly, you got to think about, how do we compensate for animations and all that stuff, and have IK take over and all that stuff? It's just a little bit of a mess. So, for Montas, we're sticking to about 175 centimeters, about the average height. That should work out, but in the future I really want to try out allowing people to set their height in game. But you got to think about gameplay considerations and all that stuff. UE4, on a side note, uses one Unreal unit for centimeters. Right, so use slow motion and free floating particles. So something that a lot of people don't realize is that, who's seen Interstellar? It's not really a big, what's the word? I can't think of it. But yeah, there's one scene in it anyway where there's, do you remember the bit where it starts spinning the big space station and all that stuff, and it just covers the whole screen? For me, I don't usually get nauseous or anything like that, or motion sickness. In that movie though, when I was super close up to the screen and it was covering my whole periphery, that spinning motion actually made me feel a little bit sick. So if you think about not just moving people's head in game, but actual spinning objects or stuff floating around people in game, that can also make them feel sick, because like they don't feel like they're there. They can kind of like track their eyes and move around it and all that stuff. But if it's like moving really quickly around them or something like that, it's like being on a merry-go-round or something. It makes you feel a little bit sick. So particles especially, keep them pretty slow speed around them, around your players, and anything else that kind of like orbits people. And experiment with art styles. There's a game that's going to be released, I can't remember the name of it, but it's very stylized and almost cartoony, and apparently works really well. I'm yet to play it, but yeah. Play around with them. Montas is more of a semi-realistic art style, so a lot of flat colors, but trying to keep a lot of detail in the geometry and all that stuff, and it works all right. So with first-person VR, position and rotation of camera is relative to the body. So in Montas, we've set up so that there's a lot of body awareness. So when you jump in game, you can actually lean around and look around, and your body will follow you and all that stuff. So we feel that, like, from the first version of Montas on UDK, where you had no body, to this version of Montas, you look down, you see your body, and it feels a little bit more immersive. But the only problem is that that you suddenly start having the issues of your head needs to start controlling animations and using inverse kinematics and all that stuff. So you've got to really start thinking about, okay, does the body actually control the position of the head, or vice versa? In Montas, I'm trying to keep the head master of absolutely everything. So when you move around and lean, the body will follow you. The body can still animate and move around a little bit, but it doesn't affect the actual head of the player, or the camera of the player. But another thing is with like animations with the heads and all that stuff, you've got to start thinking about, okay, when I press crouch, does that pull down the player's head and all that stuff? There's a lot of design considerations that you have to jump in and think about and test, especially. Like, that's the biggest thing, especially with any type of game development, just test, test, test. But a lot of problems can ensue if you try doing something a little bit non-standard. So with animations, especially for VR, we were thinking maybe we'll do the standard system. Like if you play COD or Unreal Tournament or some first-person style game, most of the hands that are in game are just like this disconnected thing that's attached to the camera. You move around, it's kind of like static to the camera. And then you've got third-person animations that are completely separate to those animations that other players, if in a multiplayer game, will see. So it's kind of like you got two separate characters, one for the first person and then one for the other characters. In Montas, we chose to just use third-person animations for everything and try and we're using an animation pack at the moment, which is called Movement Anim Set Pro. I'm pretty sure it's on Unity as well. It's pretty good. It's all mocapped animations and all that stuff, so it feels a lot more realistic. We're using all of those animations for first person as well. So the animations that a multiplayer person will see is the exact same ones that the first person player will see. And we feel that it works really well because you get more of a sense of like presence in your world. So the default implementation UE4 essentially it doesn't attach the camera to the actual head component of the character or anything like that. It just kind of like has a fixed location in space. And it's kind of very, like imagine you've got like a track or like a, kind of like a cart or something like that, and you put a camera on it and you move around, and that's pretty much what it's like. So we want to try and do something like that, but then have the animations kind of follow that. All right. So the head-mounted display has to always tell the engine what's up. So it's, as I said, the master of absolutely everything. So all of the animations in Montas that I use, we do a lot of IK to control everything. It'll lean in, turn around. This also works for multiplayer. So like when we've made the whole game really ready for multiplayer. We're building everything on our own little VR kit that we'll use. So when you jump in game, all of the head turns from a head-mounted display will be replicated to another player, and they'll be able to see all of these blended animations and all that stuff. But the problem is that, as I said, these animations can cause a lot of problems. Like, do we blend all of the head bobbing from the actual animation into the head? No, we definitely don't want to do that. So we have to have some kind of disconnect and kind of like tracking to say, hey, this is where the animation head is, and this is where the main camera is, and then kind of have some kind of like control algorithm to blend through the two. Design, you could do a few things, like designing the animations with minimal head movement, but it might look a bit unnatural. So like if you're running or something like that, you expect another player to be bobbing around and all that stuff when you're playing multiplayer. And unfortunately, if you design animations with that head movement, other people are going to see it and be like, that looks a little bit odd. You really want to like have some kind of system that disconnects, but then has it kind of IK blending in, and yeah. All right, so one of three situations: limit the head position in the Z-axis, so you could just statically keep the head position there, and then just follow the X and Y and move around, and then have the animations kind of blend through the X and Y locations. So I should say in Unreal Engine, Z-axis is up, unlike Unity, which is Y up. I should probably tell that first off. But yeah, or what we can do is we can blend in crouch animations based on Z offset of the HMD. So what happens if the user starts crouched in real life and stands up? So like when you move up and down, you could say to the animations, okay, you've gone this far, blend down. So you can kind of like see the effect that I'm saying is if you've got a user sitting downwards or something like that, you could have the body just kind of like flipping down and having no blended crouch animation or something like that. But you're going to get a few issues with that. And you could like try and move the body to play catch up. So like you could say, okay, this is kind of what I do in Montas, this third option, is you take the original location of the animation, cache that, and then say, okay, this is where the head is in relation to that original location. Are we too far away from it? If we're too far away for an animation to compensate, we actually move the whole player's avatar to that new location. Same thing goes with the crouch, is that when you crouch too low, then it goes, ooh, okay, it's outside of the original extent. Let's crouch the actual animation of the character as well. I use a little bit of a combination with everything. There's like, with the Z up, obviously, you're going to get into a situation with even my implementation where if the player stands up on a chair and goes higher than the actual character, you're not obviously going to go in-game and go, hey, I'm going to float the character up, because it's probably not something that you intend anyway. And it's really odd in multiplayer as well. So what we do for Montas anyway is we do a little thing with post-process, but I can tell you guys about that later. Do we want to turret our head? So there's a few options in terms of rotation, not just translation and all that stuff. A lot of games, when you're like moving around, when you look left, it turns the whole body. When you look right, it turns the whole body. When you're naturally moving around, you're not going to be sitting there strafing the whole day, like walking around like this. You're going to turn around and kind of like look around, and naturally your body will turn in the direction that you're moving. Like if you think about it, who here, like in real life, just sits there strafing to get around a corner or something like that? Not many people, yeah.
Combat training for that.
Yeah, like unless you're in the military or something like that, you're like holding some weapon, probably not. So like in Montas, we don't have many weapons or anything like that. There's nothing that you control. Until you get a weapon, you're free walking around. And it's kind of odd when you're looking down and you see your character doing this, but in real life you're expecting to kind of like have your body follow your trail of movement. So in Montas, we have it completely disconnected. So when you move in a certain direction, the body will start to follow, and the head can sit there independently. Cool thing is, in multiplayer, you can start getting a lot more like gesture type stuff. So you could have, we made like a little demo for a multiplayer horror game where it's like 3 versus 1. And you're running through a house and all that stuff, and you can kind of like lean around corners and twist your head around and like see where people are actually looking. And it adds in a lot of extra effect. Like when you're trying to hunt down someone, you can see, oh, they can potentially see me because their head is looking directly at me. It's not kind of like using the field of view or anything like that. It's actually, hey, the body, they're moving that direction, but they're looking over here, and you can see the head turning and everything. It's really cool. Yeah, the only problem with this thing is that when you're turreting your head, what happens with the arms? Do they blend their IK when you're like using stuff? Say if I want to pick that up and I'm looking and my body's turning in this direction, you have to start thinking about how inverse kinematics can blend in your arms and hands and all that stuff. So there's a lot of little animation issues that you can immediately see when you start using the system. But with a little bit of effort and work and all that stuff, it works really nicely. So alternatively, what you can do is you can do kind of like a canned animation, so you can come up and say, hey, I want to use that, and then the body kind of like turns over and just does the canned animation. That's probably the easiest way. But if you want it to look a bit cooler or a little bit non-standard and all that stuff, you can start working in the IK systems. But regardless, in all of these cases, that was in any certain situation in VR, we always have the head master of absolutely everything. All right, so another big issue that is definitely evident is what happens with clipping. So clipping is like when you come to a wall, and who's played a game where they've like pushed their collision through like a wall or something like that, and they can see through the time and space, basically. Yeah, it's kind of like you can see through walls. In VR, like you can potentially get to a situation where you bump up against a wall and then put the camera through. But the thing is, though, is that we don't want to stop the person's head from actually moving through, because that's going to cause nausea. But we don't really, it's like a side effect that's going to say, hey, like, do we want to punish that person and just stop that camera dead there and make them feel sick? Probably not. They're going to hate the developers. So
Cars recently, just that video. I was driving credit cards, actually stood up while I was driving along. And it's like his head through the roof.
Oh, really?
It's like simulating like a top-down view.
Oh, that's awesome. So,
like stepped to the side and sat in the passenger seat, so looked at his body. But
yeah.
yeah.
Well, I played. I hooked up my DK2 to Grid Autosport. Was it the newest version? And they haven't compensated for this either. So yeah, you could like put yourself in the passenger seat while you're driving. You just see the was it like a avatarless person driving the car, which is pretty cool. But yeah, so like immediately you can see the problems, right? Like from gameplay, if you're playing a multiplayer game, like that horror game that I was just mentioning, the multiplayer prototype that we made, you could stick your head through a wall and see through the walls and see where people are coming from. It's going to break gameplay. So in Montas, this is the one thing, is that you don't want to use post-process a hell of a lot, but in this case, it's necessary. So when you clip through a wall, you know at all times that your body's collision is always going to be at an original location, and we're already caching the original location of an animation. So we can do essentially just a raycast to check for collision and say, okay, how far are we through that wall, and then blend in like black. So you don't want to do it instantly, because when we first released the game on early access and people put their headsets on, we used to change, like when you load up a new level or something like that, it would come up with black instantly. And people would just be like, boom, it's like, you kind of like get hit by a big black thing in your face. It sounds really bad, but, yeah, like it's just super nauseating. It's something that I would not wish on my worst enemy, essentially. So with the clipping, what I do is you go, okay, well, how wide's my head? It's about, 24 centimeters away is probably around about, was the point where we want to start clipping. So before we even start, we start to blend to black. And then when it starts the collision, that's when it's fully black. So you get kind of like this little blending approach that's kind of quick, but not quick enough to make it feel nauseating. But it works really well. And the same thing goes with the Oculus. You've got your head tracking, and you've only really got about a space of, was it probably about 6 foot by 6 foot or something like that. And when someone moves out of that space, they want to at least get a warning saying, hey, you're about to move out of this, your head tracking is going to get snapped off. And if they move out of that and it snaps off, they're suddenly going to get like jerking and jittering and all that stuff, and it's going to feel really bad. So the same thing goes. I blend to like a little red. It's probably going to change in the later version of Montas, but we blend to like a little red post-process that goes, hey, you're getting very awfully close to the edge. With the Vive, a lot of demos, they use like they render in like a box, so when you get to the edge, the box actually renders in. You can see, oh, that's the exact extent of the actual headset, and that works really well as well. Cool. So, nausea from input. People using controllers and all that stuff, I mentioned this before. Usually when you turn the right joystick, it will turn the whole body. You probably don't want that because it's going to twist people's head off and make them feel sick. You don't want to have any animation inducing any kind of movement. So when you do like a punch or something like that, you might press a button for punch. Do you want that animation to actually move the head as well? Probably not. But from the most part, if you've got a user inducing that animation and they're choosing to do it, they're most likely going to be expecting it. So your brain can at least go, hey, I actually did that. Like, even if I didn't physically do it, I at least told the system to do this. So there's like little edge cases that you have to really like test for. It's really just like with testing a lot of, input and all that stuff with players and getting feedback and all that stuff, that you don't really know what you're going to expect until you try it. With any kind of input, if the player tells it to do it, it's all right-ish to an extent. Just test. So like for Montas, with the punch systems and all that stuff, we try and use animations that look pretty natural, but because we're using a little control algorithm, we can kind of like blend through a little bit of the animation. There's some stuff that you can't get away with, because if you start the punch, like obviously your shoulders are going to be brought forward, and if your camera doesn't move with it, you're going to start seeing your player's avatar kind of like move forwards and like a headless body in front of you. So we do a little bit of blending, but it's not a hell of a lot. And there's no way of avoiding any of this input. Like the traditional stuff, so like mouse and keyboard and all that stuff, you're always going to have people who are using that, especially with Oculus releasing their platform with an Xbox controller. We're going to have to use that Xbox controller or assume that that's the lowest common denominator. And then some of these headsets will have extra peripherals as well, like hand controllers and all that stuff, and you have to start thinking about that. Personally, we don't use hand controllers at all in Montas. We're probably going to avoid it for the most part. I might experiment with some input and all that stuff, like picking up objects and opening doors and all that stuff, but it might not be in the final release. And then finally, for any type of movement, I mentioned with was it the right joystick, turning the whole body. A big problem with that is that some people will be like sitting in a chair and you can't turn around completely or anything like that. And that's going to limit your gameplay, right? So there's stuff like VR Comfort Mode, which does like an instant snap. I'm a little bit skeptical, but I hear it's pretty good, where you kind of like tap the controller right, and it'll kind of snap was the body at like 30-degree increments or something like that. And it works all right, apparently, but I haven't personally tried it. But overall, you can see that VR dev is like a bit of a pain in the butt. So you really got to like play around with a lot of things. But
who came up with this name, VR Comfort Mode?
It was a studio over in the States. I can't remember the name of the studio. But they basically were experimenting because they were making like another first-person VR experience, and they were always experiencing people like, because with the DK1 and the DK2, you get only gyro like control or tracking when you go past a certain extent. So with the dev kit 2, you've got all of your little sensors, like your infrared sensors are on the front, or the emitters, I should say. And when you turn further than about 180 degrees, or a little bit further than that, I should say, the motion tracking will cut out and you'll start getting jerking and you can't get the full tracking. So you really want to be like facing at the front at all times like that. So that obviously limits your like mobility. The consumer version of the Oculus does away with that because they've got tracking on the back, which is all right. But overall, you still, with like older versions of the Oculus, that's where comfort mode comes in, because you can kind of like still turn and then snap, 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 and then recenter yourself or something like that, which is, yeah, like I can see the reason why they would use it, but it's kind of like that instantaneous snap is a bit weird, but at the same time, like a gradual lerp is probably going to be worse as well. So it's like the better of two evils, I would say. But yeah. All right, so why Unreal Engine 4? Was it, like I'm not a Unity guy. I've used Unity a little bit, but there's like a few things that I can immediately say. This is the stuff that I've chosen that I can definitely say is better than Unity is the shader system. Like there's no need to actually like hand write your shaders or anything like that. You can use I wish I could zoom on this actually. You can use, was it like a node-based system to connect up all your shader math and all that stuff and see it real-time updated. And it's pretty cool. There's also the same type of node-based system as for scripting. So I think Unity has a like a node-based script.
It's a plugin, I think.
Yeah.
Playmaker.
Yeah, that's it. Playmaker. Yeah. Unity has Playmaker, but you have to buy that separately. Whereas Unreal Engine has kind of like Blueprint built into it, which compiles down to bytecode and is pretty efficient. It's only about 8 times slower than C++, but apparently in the next few versions of Unreal Engine, they're going to try and convert that from a bytecode system to an actual native compile to C++, which is pretty cool. So hopefully it's going to be one-to-one speed with C++, which I'm happy about.
It was a bit funny about the blueprints. So I went to that Unreal workshop where they demonstrated it. And
yep.
I thought it was great and I sort of came out there wanting to use it, but one thing I thought was funny about it was that it had like casting. But you had to have nodes for casting. It's like one of the most sort of evil things about programming.
Yep.
They put in the kind of user interface for it.
Yeah. It's like a super abstract concept, and a lot of people are kind of like iffy about what casting is. But yeah, like once you start getting used to it, like my co-developer, who's not a programmer at all, he picked up blueprints within a week, and like he wasn't super like proficient at it, but now he's just like a gun. He writes a hell of a lot more blueprint than code, let's just say that. And like he can get a lot of good results. Like he does a lot of level scripting using Blueprint and all that stuff. And he does a lot of gameplay design and all that stuff using Blueprint. So it's very powerful. And yeah, like saying that though, I've got it up on the slides there. I would still create a C++ foundation though. Like you can't beat it because the problem is that as soon as you start using version control systems, this is probably more game dev related rather than just VR. But if you're using version control and you get like a conflict in Blueprint, you're going to have to basically copy paste out nodes into the old unmerged version and all that stuff. It's a bit of a nightmare in terms of version control. Great though for quick prototyping. It's like super awesome for people who just hate syntax of programming. So I think it's a great way to learn programming, but yeah, results may vary. And the animation system as well. It's kind of similar-ish to, was it Unity's system? What do they call it again?
The new one's called Mechanim.
Yeah, Mechanim, that's it, yeah. So it's kind of like similar, it's all node-based and all that stuff, and got states and all that stuff. But it's mixed in with the Blueprint system. So you can use Blueprint to do scripting rather than having to use tags in Unity and all that stuff to go, hey, this is the location where this animation should start or something like that. there's stuff like animation composition and anim montages. So you can get multiple different animations, put them together, and put like little tags that can fire off blueprint events and all that stuff, and use them as what's called montages. And they can control flow of the animations as well. They're really powerful. And the particle effects system, which is called Cascade, they're going to like eventually deprecate this and turn it into Niagara, which is another cool one. They're going to do the same thing with the the material system as well. Use a new one, but the particle effects is really awesome. It's basically like it's called Cascade. You put like little nodes in there and tell how the particles move in space and their color changing over time and all that stuff. Yeah, it's pretty powerful.
So why Unity?
Sorry?
Why Unity?
Why Unity?
Yeah, so Unreal Engine 4 is good. Why would somebody choose Unity over
I think that like Unity it's like familiarity and also like quick to prototype and implement like simple solutions and all that stuff. But like if you're already like super competent with it and all that stuff, like I can guarantee that Phil and Ash are probably going to be like, yeah, I would be able to do absolutely everything that Unreal Engine does. But I think like it's mostly for me familiarity. Unity, I can definitely see that I would use it for like projects where I do mostly single player games and all that stuff. But because I'm personally wanting to go into multiplayer, Unity doesn't have a lot of stuff. I know Unity 5 has their replication system starting to build in, but it's not as mature as Unreal Engines. But there's a lot of stuff in Unreal Engine that is standard that Unity doesn't have, like e.g. the scripting systems. So you have to use Playmaker to do level scripting unless you want to use C#. So you would still have to use their components and all that stuff to do any type of level scripting, unfortunately. But yeah, like out of the box.
It takes a pretty different perspective. Like it's very geared towards artists and designers, so it's very easy to get into if you're not a coder.
Yeah.
Whereas and not having too much experience with Unreal, I would say it's a kind of older-fashioned, more mature engine. It's better for coders, and I think they're probably catching up with Unity on that use as well. Anyway.
Like I would say that Unreal Engine is a lot easier for like level designers. Like Unity and Unreal Engine, you can put together everything, like put it into the level and all that stuff. But then in Unreal Engine, you've suddenly got level designers able to script those events. They don't have to like use C# to do all of those events. And I see a lot of level designers like dabbling in C# and they struggle with just the syntax. Whereas blueprints, I can probably, after this, I'll open up and give like a little demo. But blueprints, you don't have to worry about syntax. You can just drag and drop off a node and it will tell you all of the functions that type of variable can use. And then it's pretty intuitive, but you still have to think about everything in object-oriented like design and all that stuff. So yeah, it's like it can be as complicated as you make it. And yeah, like I would say this with a fair bit of grain of salt that any type of game development is definitely going to be complicated as soon as you get to like shipping stage, because you're gonna have to start thinking more about, hey, like Unity has built-in serialization and all that stuff. UE4 does as well, but it's a little bit of a pain in the butt. You would still have to do C++. Whereas Unity, you can serialize out of the bat, but you still have to use C#. So you gotta have this trade-off. Hey, do I want to use a more complex language, but have was it UE4's like simplification of the language in there? They use what's called a reflection system to make things more simpler for the C++ side of things. But overall, UE4 in the long run, probably more complicated than Unity. But I feel that Unity gives you next to nothing to start with, except for some of their starter packs, and you can build on top of them, but you're probably going to be rewriting a lot of stuff. Whereas UE4 has like a framework that's already there that you can build on top of, and it takes a little while to get used to that framework first off, but I feel that overall, like the structure of the framework and all of the scripting and all that stuff can really like aid in like honing your design of your game and like making sure that it works really well. Because like a lot of people who start off with Unity, I can see that Unity is great for simplification and all that stuff, and the component-based system is awesome. But if you have never programmed a project or like done a large-scale project, it quickly gets complex. And if you don't have an existing framework to build upon, then you're going to have to start making like really high-level decisions like, hey, should I use this component for everything? Or should I start inheriting from this component and starting to think about like a lot of software design? And kind of UE4 kind of takes that initial design from you, designs it itself, gives it back to you, and then goes, hey, try and design around this. And it has its limitations, but overall, I think like when you start getting used to it, it can be very beneficial. And I even go back to Unity, taking a lot of those design paradigms and applying them back into Unity. So it's probably like, it's a very different style of game development, I would say, except for the level design side of things.
Unity's component system is really great when it's what you want to use.
Yep.
But like the problem is when you use Unity is you have to kind of shoehorn everything into that design pattern.
Yep, exactly.
Like there's no way out of it.
Yep.
Whereas I think with Unreal you get a lot more flexibility. You could use
Yeah.
it if you wanted to.
Yep. Yeah, so like Unreal Engine can use component-based, so I should probably, who knows what I'm talking about? I should probably do a little tutorial. So in most games, like in Unity, you've got game objects, which is kind of like the physical, well, not physical, but the representation of like an object in the game. UE4 calls these actors, and with each of these objects in game, you've got components. So you can add in like a mesh component, you could add in like a movement component, something that controls people's movement and all that stuff, and it kind of like encapsulates a lot of your functionality in those components and links them back into the game object or the actor. And Unity only allows you to use components. So you have everything as a game object, and then you just add components. Whereas UE4, that actor/game object can also be subclassed to give some kind of like, behavior and all that stuff, but then you can add on top components. So it's very different like design paradigm. I would say that UE4 can be used exactly the same as Unity, just with that added extra complexity of the actor. So it's like Unity is great to simplify things first off, but then can quickly get complex, whereas UE4 starts complex, but then kind of like teeters out and stays complex. So it's like, yeah, it's kind of like trade-off, but once you like start off complex and you start building your games and all that stuff in Unreal Engine, and you get used to it, it's easy from then on. But yeah, that's from my experience anyway. So yeah, sorry, went off on a bit of a tangent. But yeah, so once more, why Unreal Engine 4, 5% royalty. It's free, you get all of the source code. So as a programmer, I was a big fanboy of that because developing in an engine where you don't get to be able to have proper debugging symbols or be able to like step through the exact code that was run, or maybe there's something in there that's undocumented in the engine and you're like, how the hell does this work? I don't know. Let's just kind of guess our way around it. That was like a big problem to me. You probably have guessed I'm more of an open source guy, so having the source code was like a big part of my decision. And it supports Windows, OS X, Linux, Android, iOS, Xbox, yeah, PS4, and HTML5. So a lot of platforms out of the bat. And how easy is it to test VR in UE4? It's literally just click that play button, the arrow to the right of the play button, select VR preview, and done. And that's pretty much it. So, come on. There we go. Sweet. So, homework for you guys. So if you guys want to have a look more about, development of VR in UE4, or even just stuff about UE4, check out Nick Whiting's and Nick Donaldson's talk in Oculus Connect 2014. They go a lot about their design of the Showdown demo, which is kind of like this cinematic style railroaded demo for VR in UE4. And it's a really cool talk, so check that out. I'll see if, I guess you guys can put links to these slides online? Yeah, sweet. So we can put the links to these slides online anyway, so you don't have to jot these down. And then, yeah, a lot of the tutorial videos for Unreal Engine are pretty damn awesome. Zach Parrish is a really cool guy. He used to do a lot of tutorials for 3D Motive, I think it was, or something like that. And then he went to UE4 as like a content lead. Yeah, but it's really cool. And then Oculus Best Practices Guide. If you're developing for PSVR, they also put up a Best Practices Guide as well. It's really good. It's like the Bible that you should probably follow, just because like you've got all of these guys like Michael Abrash and all that stuff kind of going, hey, this is what I've tested in VR, this is what works, this is what definitely doesn't work, and they're basically just expunging all of their knowledge into one document. And then there's the Unreal Engine 4 VR Best Practices Guide, which is really just an addendum to the Oculus one. But yeah, that's pretty much it. So questions? Yep.
Can Unreal 4 Engine use C#? Because I'm a beginner, so I'm learning C# at the moment.
Yep. Actually, I may as well show you a bit of scripting from UE4. Will this go over? No. We'll quickly.
There's an open source project where there's like a plugin you can use to use C#.
Yeah, I remember that the guys over at Xamarin started a plugin for C#, but like it wasn't officially endorsed by Epic, mostly because if you're starting to support more languages and all that stuff, you get a lot of dependency issues and all that stuff, and then, yeah, it turns into a nightmare. But the, come on, question for the Mac users out there, how do we actually get this duplicating? It's one thing that I've never used. It's what, sorry?
On the window on the laptop screen.
Okay. Arrangement here. Is it? Yep. Dope. There we go. Sweet. Awesome. So that should be it. Hopefully, here we go. So was it C#? UE4 has its own garbage collection system, and it uses a reflection system called the UObject system. It really makes things super easy. I'll see if I can zoom this in. Damn it. There we go. Lovely. Come on. Nope. Apparently two-finger zoom doesn't work. That's lovely. So probably can't see it, but like for functions and properties and all that stuff, you can mark stuff with uProperty, and like serialization can take over there and all that stuff. But for any object that is instantiated in game that's derived from UObject will be marked in the garbage collection, and if there's no more references to that, it will delete everything. So it's pretty much the only difference between Unity C# and UE4 C++ is that UE4 supplies this UObject reflection system, which does all of the garbage collection for you. So I would say that like if you're used to the differences, like the biggest difference between C++ and C# for UE4 is pretty much like the difference between references and pointers. So if you learn those two things, you should be able to get by pretty easily. And there's like a few little things like, in C#, you've got the out keyword. In C++, you've just got the ampersand character. So it's kind of like, there's a few little transitions, but you don't have to worry about memory allocation. It is like the biggest thing that they wanted to do for UE4 C++ is like just take out the whole difficulty of garbage collection and memory leaks and all that stuff. So yeah, but you can go as low level with C++ as possible if you wanted to, but like for the most part, it's really just C++ scripting. It's not full programming, but yeah, but just try it out. There's a few tutorials online, and it's not too bad. But another thing I should say is header files are probably going to be a bit of a shock for you as well, coming from C#. So header files are kind of like, C#'s assembly, like an assembly type thing, where it's kind of like a public-facing thing that allows you to define declare something, and then you define stuff in the CPP file. But yeah, you'll check it out anyway. But yeah, any other questions? Yep.
As far as people who usually wear glasses or contacts or anything, is there an issue there when using a headset like? Yeah,
with Oculus, they do supply different lenses and you can swap them out. PSVR, no. PSVR, like the one at home that I've got, you can press a button and it basically slides the headset to and fro, and you've still got like a little rubber plate that kind of pushes against your face to stop the light from poking in. But it's not an issue on PSVR. It was like their number one thing that they were trying to design for was for everyone. So they were like, we need to support everyone who like in our demographic, and most people in the demographic wear glasses anyway. So it's like, yeah, like they had to support it pretty much. So yeah, so.
VR has a little kind of dial thing on the top that adjusts the focus.
Yep.
That's really cool feature.
Yeah. So.
As you need glasses to see the distance, you just need to wear your glasses in the headset. If you use your glasses to see things close up,
Yeah.
you don't need it in the headset. It's effectively the light inside the headset comes from an infinite distance. So it's like simulated like long distance vision.
Yeah. Any other questions?
I was thinking a lot about the cars video, actually, with the standing up and going through the top of the roof a lot lately, and I was thinking about that when that was brought up. But and I was thinking specifically before about the ways you would stop that, and how you were mentioning that you don't want to constrain the head.
Yep.
Makes sense. So presumably it's not viable for that example of leaning through the pillar. If you just treated that as like almost like you're pushing the character out kind of thing.
Yeah, like the problem with that though is that that character, like the camera is still going to be squished, and then the character sure can like do that, but like your head in real life is still going to move through that pillar, like regardless.
In that case, it's like the body moves sideways to compensate so your head never goes quite through the pillar.
Yeah, like that can be done, but
jarring feeling? Is that
yeah, because like that peripheral is still over your face, so like it's still like if you put there, like get stuck there and the rest of the body moves, you can see that my head doesn't move in this regard, and like it still looks static, but physically your actual head is still moving through.
Yeah, I mean, it's obviously, because the other case is a game where you're allowed to crouch.
Yeah.
You can crouch under something.
Yep, and you can kind of like
And
pop
then
your head up.
stand and then
Yeah.
because you follow the rule of not ever allowing the game to constrain you, there's no concept for the game to say this is an illegal action.
Yeah, so like for my animations and all that stuff, what I do is I kind of like that, the raycast that I use also like limits the animation, like the physical animation and its IK and all that stuff. So like, was it a person in multiplayer, when they look at another character, if they're moving their head through, they don't see the actual, like, they don't see the camera moving through, they just see the head, and that's it. So from the outset, it just looks like they put their head into the wall and kind of like they're just stuck there. So that's cool. But then on the client side, who's putting their head through, that's when, for my algorithm, was it their head, like the camera in game will still move through, the head will stay here, but then the post-process effect will kick in. So like that's what I found was the best option without giving them a kick up the butt and kind of like punishing them for it, because like the problem is as you said, like if they go underneath a desk, obviously people standing down on their knees like all day trying to crawl around like a turtle or something like that is going to get pretty painful.
It's not that, it's like the invalid situation of you crouch down and then you go, okay, you're now low enough to fit under the lock object. And you stand up and now you're in the game.
Yeah, you're above it.
Small enough to fit under the object.
Yep.
In any other game, you would just like the crouch button wouldn't stand up anymore.
Yep.
Obviously in VR, you don't want to. You're stuck with the game logic says, well, you can't stand up now, but you said, well, I just did.
Yeah,
And
yeah. Yeah, so like, yeah, that's where my, was it the raycasting will stop the atoms. Like I'm not going to stop the head, but it will be black. So they'll have no idea except for like, this is the next thing that I want to put in is kind of like some kind of like indicator to say, hey, this is where your original body was. Because like you could get into positions like, especially with the Vive, you could walk physically through that wall and then the body would be stuck there. Do you have like some kind of navigation system, like using NavMesh to walk the body back around the wall? Or do you just say, hey, the body's stuck there, move back in that direction? So they have to walk their body back through and then walk around it. Like, there's these considerations that they sound ridiculous, but it's something that has to be compensated. And like, until I get the Vive, it's something that I haven't played with yet. But yeah, like with the Oculus, was it because it's got such a small field, you don't have to worry too much about that, but I'm still going to put in some indicators to say, hey, your body's back here, buddy, like, you might want to move that way. Yeah, so something kind of subtle though, because you don't want to be like, burr, 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 like kind of like in their face and kind of slapping them every single second, but yeah, yeah.
In some ways, the driving example, you're in a car, you're sitting down, and you decide to stand up in real life. The most valid thing to do is almost basically say, the game's not playing anymore. Like, you know,
yeah, like just
sitting position.
Yeah, like
You're going to have to cater for it in your game design.
Yeah.
Yeah.
Like it's like if you walk outside the boundaries of the game world because you're using the Vive or something and you just go where you want.
Yep.
You've given them some indicator to show that they walk through a wall, but then you give them like 10 seconds to come back or the game ends or something.
Yeah, so you could do like the Battlefield thing where it's like, you've got 10 seconds and then you're out of the battlefield, yeah. Or, yeah, pretty much. But yeah, or like, was it with the car example, if it's only a single player game, I can totally see like, if you move your head out, it just slows down to a snail's pace and kind of like goes slow motion, but then once again, game design comes into it. Like, do you really want people like slowing down the pace of the game, just going, okay, I'm coming up to a really hard corner, like let's just take this a little bit slower, and then they start like abusing that. Like if you give someone the power to abuse a game, they will do it. So like, yeah, for me, like the post-process effect was the only option I could think of that would work really well when you're doing the clip, because it stops them from abusing the game. But then the problem is that they can get lost in that black space until you give them that notification. But it stops them from abusing it.
Like your wall cavities with like horrific images.
Yeah, you could do that as well, yeah. So all those back-facing polys could be just populated with something horrendous. So, but yeah, like I think that it's like one of those things where there's like a lot of flexibility in this, but until we test it a hell of a lot or like play around with it and see other people using it, like it's like the film industry at the moment. The film industry has been around for like 80 years and it's gotten all of this time to mature and we've gotten really good at it, and now we've got this new medium where we're like flailing in water and trying to like stay afloat, and we've got best guesses, but until we like put it out there into the public, people aren't going to know. And there's like quite a lot of like demos, like the Portal demo for the Vive. I haven't played it yet, but it looks really cool, where they don't use, like how I was mentioning with the normal maps and all that stuff. All of the objects they have in that are all physical geometry, but it's just a small space. It's just like walk around in like this, this 15 foot by 15 foot space, and you can just physically sit there with a controller and play around with things. And it's like constrained in your world, which is awesome. But the whole game's designed around that VR application. So a lot of people go, I want to play WoW with VR or something like that. And it's like, well, yeah, you could, but you might not be getting the best experience. Whereas like games like Epic's Bullet Train, where it's kind of like you teleport around and you've got like your special ability is teleport and then shoot people up and then walk around and then teleport again. Stuff like that is awesome. There's another game, I think it's, is it called Business Cuts or something? Budget Cuts, that's it, yeah. And you're in the Vive and you're like throwing a blade around and destroying robots and all that stuff. That's awesome because like, you've suddenly got this art style. It's like basic looking robots. There's no blood, no special effects. It's just very simple. You can keep the high like frame rate the experience is going to be really cool, and it's fun gameplay, and it's very designed for that hardware. So I think like the biggest takeaway is definitely don't use an existing like genre. Use an existing genre, but modify it and like turn it into something completely different. You want to really like start designing your game from the ground up to be VR like supported. There's a lot of games that are going, yeah, like we'll support VR in the future, but they're not designing it from the get-go. It's like, that's not going to go well. Like they're probably going to have to like rewrite a lot of their game just to support it. But yeah, is there any?
Just an audio-related question. What's Unreal's engine like for integration of 360?
Yeah, like
audio?
they've got basic spatialization, but they don't have any. Is it HIFM? God, I can't remember what it's called. They don't have like was it that the modeling in like built in yet? I think they're working on it at the moment, but like something that PSVR does out of the box does all of that spatialization properly for you. Oculus, not quite yet, but they're working on it at the moment. So UE4's sound system needs a big overhaul. It's been pretty plain and lackluster since UDK. It's still using the same system since UDK. And I think that's on the cards that they're going to be swapping that out very soon.
It does integrate with Fmod though, doesn't it?
Yep, yeah. So you can get a plugin to use WIs and Fmod. So if you really want, yeah, you can use those. But it just means that potential royalties or parting away with your wallet to some degree. So yeah, but yeah, Dylan.
So I've heard a lot of like, I guess, opinions and arguments and stuff about the direction that VR is heading, and I've never gotten that much into it. So for now, I haven't found anyone I can actually know if that's what's agreed upon. But is this the VR community still kind of in this like turbulent state? Because I heard someone say the other day that, oh, VR, people will get used to simulation sickness and we'll be able to do a lot more. But I've heard other people say that VR will never be viable because simulation sickness will always strike X percentage of the population.
Yeah, like I think that simulation sickness is definitely going to always strike. Like we haven't even solved that problem for cars. Like people are still getting sick in the back of a car. And even no amount of pills is going to try and like support it that much and like fix that problem. But I think that the next generation of gamers, that's where it's going to be at. Because like you've got, like we had a demo where, it sounds really bad, but these 6-year-old kids were playing Montas. There's no blood or gore in it, by the way. So yeah, it's pretty PG. But yeah, John Passfield's kids jumped in it and like, no nausea at all. And I was like, you lucky little buddy. I was like so annoyed because they could just jump into it and their brain just goes, this is awesome, I'm gonna accept this. And like if they're gonna grow up with this tech, man, I'm jealous because like they can just, like their brain can just learn to accept it. Whereas like when you're an adult, it's like that sponge effect that people always talk about. When you're an adult, your brain isn't as spongy. It's not going to just take in information and accept it as is. It's going to push back on it. And that's what nausea is. It's really like when you get that sickness, it's because your brain senses something is wrong and goes, I don't know what to do, throw up. Like, it's pretty much it. It's like poisons. Like, what does the body do with poisons? It goes, well, I don't know how to get rid of this pathogen. I'm just going to throw up because that's the first option I've got. It's obviously been induced, so blah. But then, yeah, the same thing goes with virtual reality. Your brain is trying to reject the hell out of it. As much as you want it, it's like, nah, I hate this. Like, I can't take it. And I've heard that people who use it enough can get over it, but I haven't yet. So, yeah, that's indicative. But yeah.
The tech is still changing as well. As it matures, the rules are going to change basically. So what we think we know now is probably going to change over the next 5 years or so.
Yep. So like it could be that was it augmented reality is the next biggest thing. Like I've talked to a few other guys and like augmented reality takes away the biggest problems of VR because it's like it's like augmented, it's like your head's in real space. You don't have that latency issue except for the stuff that's superimposed. So when we start getting that superimposed stuff rendering really quick, which is pretty easy these days, because it's pretty good. But with VR, like you still got that, hey, it's like covering your whole peripheral. You still got that delay between your movement and that the response to the motion to photon latency is still going to be pretty high. And there's always, no matter how quick we get it, always going to be a certain like discrepancy. Whereas augmented reality, I have high hopes for, but it just means that we're going to have completely different applications for it. Like you can't, like unless you get like a full periphery augmented reality, like you can't really put them in a completely different world or virtual space. It's still going to be like superimposed over your existing space. So like that multiplayer horror game, was it that I prototyped with my co-developer for VR? Like I can imagine that being awesome as like a LAN party style thing where you're like running around in your own actual house trying to run around and stab your mate in the face physically there, but then superimpose extra stuff like blood effects and all that stuff.
I've seen that.
That's
There's a headset uses pass-through cameras, so everything you see is actually through the cameras and then into the headset, and actually blends from augmented to full virtual reality.
Yeah.
So just immerse or like a hand came to the roof and took you out of that into sort of like a fantasy world.
Yep.
Sort of thing, so.
And then there's stuff like Magic Leap, which is, they got bought out by Google last year, I think it was, or something like that. And that's like probably the most promising sounding virtual reality, but we haven't seen much of a result from them yet. But HoloLens is looking pretty good as well, but it's still one of those like infancy days. Same with VR. Like there's just a lot of stuff like it's like a lot of people are like going, hey, how do we apply our existing knowledge to this new tech? But we're just going to throw it out and start again pretty much. So, yeah.
The scary thing at GDC was there's so much VR around, like it's just a pervasive thing, and there were so many developers and people kind of chasing that. And the practical thing is that nobody quite knows what's going to work. A lot of people are going to throw a lot of things at the wall.
Yep.
And a lot of people are probably going to fail, and we're not going to talk about them very much because that's what we do.
Yeah, yeah.
And there's a bit of a pervasive feeling that a lot of the big players were relying on indies as
their trump card. Yeah. Yep. Yeah.
They'll go off and they'll make small projects, and somebody will figure out what we're going to use this stuff for, and we don't know what it is yet, which is a little bit unnerving to be exposed to when considering new projects. Because
like, it sounds really bad, but I agree with that. Like, indies are the most, like, if I haven't personally worked in the AAA industry, I know, Tim, you have to some degree, and you guys have as well, but like, AAA, they're usually like working on, it's like movies, you working on something so high budget, you want to make sure it pays off. So you're like looking at other people's games, pulling all of the best from it and putting it in, and kind of like trying to make a game that appeals to the mass audience and not experimenting with new stuff. So like with VR, you've got this brand new medium that is a risk. Yeah, like to a AAA studio, how many AAA studios these days go, we're going to make VR stuff? The only studio I can think of is the guys who make Eve Valkyrie and Eve Online and all that stuff. No other AAA studio.
They're funded by Oculus.
Yeah, exactly. So like the only people who are like invested in it are the people who like Oculus or PlayStation and all that stuff. And even then, PlayStation, like Sony and all that stuff, they're not making a VR game per se from their studios except for the deep demo, and that's really just from their research team. It's all tech. So Sony are invested in hardware, and they're just relying on the indies and any other studio to get onto it and kind of like check it out and experiment with it. But yeah, it's like you need small little lightweight teams like us indie studios and all that stuff to kind of jump in, and then those AAA studios are going to jump in and go, hey, that works well, that works well, that works well, and then reap the benefits. But you hope that the indies kind of like take it and do it really well first off. So yeah. Yeah.
To cut off
Cool.
because we've got the next
There is.
talk coming up in 10 minutes. But I'm sure Alex is going to hang around for a
Yeah,
while.
yeah,
So
definitely.
you can feel free to ask questions there. But thanks, Alex.
Cool. No worries. Thanks.